Good morning, everybody. Okay, becomes the second part then of our previous lesson dealing with a review of our primary curves and introducing our tan curve. What we're going to talk about is how we make what we often refer to as general statements. So the first thing I'd like you to do is take a look at the instruction to 1. I want you to draw a sketch of what y equals cos theta looks like on the grid provided. So let's pause the video right now and let's see if we know our cos curve well enough to provide a quick sketch. Okay, and we should be back. And so for us to sketch our cos curve, we should be good that our cos curve starts at the top and then falls. And on every axis, we go from a max to a 0 to a min to a 0 and so on. So using those key points and then being able to provide a decent curvature, curving up and then curving down, we should have that as our sketch. Now, what we also want to do is be able to extend that then back to negative 2 pi. So we should be able to good to go pi by 2 backwards puts me on an axis, pi by 2 backwards puts me on the min, and so on and so on. And so therefore, if I connect that curve using that same curvature, then we should get to something like this. This being the graph of what cos theta looks like if our axis is theta. And so we've done the first step of that instruction. And now what I'd like you to do is I'd like you to go through and deal with the second part of that instruction. So where I've said locate 3 points having the coordinates theta 1/2, there are more than 3 points that have that. What I want you to do is just circle on your graph any 3 points that have the location some angle theta and a y value of 1/2. Okay, pause the video, go to it. Okay, and we should be back. So in that instance then, maybe we looked across and we said that this was a value of 1/2. We noticed that this was a value of 1/2. We also had a value of 1/2 at these points. And now what I'm going to do is I'm just going to label those points. So if I was to work with probably the easiest one to come up with, it would be this one that exists at an angle value of pi by 3, and we know the y value of 1/2. This one at the end of that first positive rotation is a pi by 3 backwards, so I'm at 5 pi by 3, because I'm a pi by 3 short of 2 pi. To then work my way backwards, I would be negative pi by 3 and the 1/2. And then if I go all the way to the other end, I would be at a negative 5 pi by 3 and a 1/2. So if you take a peek, all 4 of those points satisfy some angle and a y value of 1/2. Okay, now we've got to jump in and deal with the last question. And that last, or part of the instruction, which is write a general statement for the theta values having these coordinates. So where I want to kind of go with this is what is a general statement, and then obviously how do we write it. So when we talk about a general statement, what we notice is these would be all the values that we see that have a y value of 1/2. But because we know that our trig curves can go on forever and ever and ever in both directions, there are infinitely many angle values that would give a y value of 1/2. We know that we would have another one way down here, and then as that curve produced, we'd have another one here, and another one here, and so on, let alone then in the positive direction. So if we were to try to answer the question then, okay, what are all the possible values where you could have a y value of 1/2? Then we need to be able to write a statement where we could generate all those possible y values. So one of the things then that we need to address is, well, how many statements would satisfy every possible value of 1/2? So there is an initial question that we always want to ask ourselves as we work our way through. And this is a question that's going to help you to determine how many statements you need. And so the question you always want to ask yourself is, do the y values, the value of the function that we're dealing with, occur at regular intervals? If you can answer that question, then depending on how you answer it, that's going to dictate what we need to build. So, for instance, if when you went to answer that question, your answer to that question was yes, they do occur at regular intervals. Well, then that tells you that you only need one statement. And we ought to find that easier because only having to write one thing is quicker. However, if our answer to that question was no, then we're going to need to create two statements. So you start to then address, well, why two statements? Well, take a look at your curve right now. Let's say I was going to focus in on one of those values. And probably for us, like one of the easiest ones, I'm going to focus in on this value at a half. So specifically, the coordinate of pi by 3.5. I want us to notice that the distance between that point and the next time that we hit that value, going in one direction, versus the next time that we hit that value going the other direction, it's not the same distance away. That one distance is longer than the other, and so our answer in this question would be no. So that key point that I found then is going to represent, or what we're going to need out of that, is going to be where I'm hitting that value of a half and how I'm hitting it. So I want you to notice that as I progress to the right on my curve, I would go through that point at pi by 3 as I'm falling to that point. So what I need to address then is one case, or build a statement that represents falling to a value of a half. So how would I write it then? Well, I'm writing a general statement for an angle, so my angle, theta equals. What is the value at that particular point? I'm at a value of pi by 3. And then what I would like us to notice is that what we have is we are hitting that value at pi by 3 and falling to a value of a half every full rotation in either direction. So I would get back to another point where I am falling to a half if I went one full rotation forward. Now, maybe we can visualize that you would also get to another point, another full rotation after that, and then another full rotation after that. So how far apart are all of our points? In this case, what is a full rotation on my coast curve? It's 360 degrees. So if I went 360 degrees forward, I would then hit another value. So since we're talking about radians then if I went a full rotation forward, 2 pi forward, I would arrive at another value of a half. But because if I went 2 full rotations or 3 any number of full rotations forward, I'm still going to land at a value of a half. And so what I need is then multiples of full rotations. And so what we do is we then multiply that by k, as long as we define that k has to be an integer. So it's got to be a whole number. Now, the other part, and maybe where we jump in on the k must be an integer, is that you'll notice if I went backwards a full rotation, then I'm getting to another point where I am falling to a half. So that's why it's an integer, because we again could deal with positive or negative. in either direction, I would be falling to a value of a half. Now, let's just clean up the form of that a little bit. Because k represents an integer, then we often pair it up with the 2. Because what we're saying then is any full number of rotations. So 2k pi will allow us to arrive at that case. Now, a couple things in terms of some stuff that's generally understood. If we all have an agreement that when we use k, we know that it represents an integer, then we're not going to have you write k is an element of I as a restriction in every general statement you create. Instead, if we see k being used, we understand that it represents an integer. You don't need to include it. Okay, there was the first part for us as we dealt with falling to a half. What we want to kind of zero in on now is going to be, well, what happens if we were in the other case? So, I've created a statement of when we are falling to a half. Let's now examine the other case of where we are rising to a half. So I pick any point on my graph where I am rising to a half. And so maybe we pick way up here at 5 pi by 3, or maybe we pick here. There is no one answer that is correct. You can pick any of those values. If I'm kind of lazy a little bit and I want to deal with something as close to the beginning of my curve, as close to the y-axis as possible, then maybe I think about this statement. So, rising to a half would then be a theta value of negative pi by 3. There's a value where I'm rising to a half. And then if I go any full rotation in either direction will allow me to arrive at another point where I am rising to a half. So if I move any full rotation plus my 2k pi, I'll get to another value where I'm rising. That with both of these statements combined, I have now taken into account every possible case on my coast graph that would have a y value of a half. So this is still pretty new to us, and we're starting to build on this. So what I want to do is I want to now take a look at problem 2. So what you'll see in problem 2 then is we're talking about our sine curve. So let's pause the video, put on a sketch of your sine curve. Okay, we should be back. We know our sine curve starts in the middle and rises. I hit my max at pi by 2, my 0 at pi, my minimum at 3 pi by 2, and I'm back to 0 at 2 pi. We're going through and we're creating that sketch, and we can do the same thing going backwards, thinking about each quarter. And there is a very quick sketch of our sine curve. Now, what you'll notice is within problem 2, I've asked you 4 different questions. So, when you take a peek at A, B, C, and D, let's start with each one individually. So, let's take a look at A. What I might do is on my sine curve, I'm going to go through and I'm going to mark every point on that sine curve that has a value of 0 with its question number. So A. Well, there's a value of 0, there's a value of 0, 0, 0, and 0. All 5 of those points have a value of A. What I could then do is keep progressing, and now if I was to look at B, I need all my values that have a negative 1/2. Well, there's a negative 1/2, so is there, and so on. What I'd like to do is I would like to go through A and B now so we can kind of see how we could go. We've got a little bit more experience. We should be a little bit better with general statements, just a little. So the question I always ask myself at the beginning, as I'm tackling problem A to write a general statement, do those A's, those values of 0, occur at regular intervals? And what I notice is every one of those A's are the same distance apart. So my answer to that question then is yes. And since they do occur at regular intervals, then I only need one statement. It doesn't matter whether I'm rising to that 0 or falling to that 0. They're all equidistant apart. So for me to come up with that general statement, I'm solving for theta. I'm going to pick one of those values of 0. So I'm going to pick one of those A's. And I think the easiest one to pick would be at 0. Now, some of us are going to want to write this. Right now I'm at 0. We'll talk about that in a second. Okay, now what I have to say is how far apart are all of those A's? That is, how long does it take to repeat to the next A in either direction? And you'll notice that you're pi units apart. So I could then say that any multiple of pi puts me back on a point that includes an A. Now, we look at that statement and we say, okay, that can be simplified. There's no point in writing 0 plus k pi. And so instead then what we do is we reduce it. We simplify it. So I'm just going to get rid of all those markings on my diagram. And what we can then reduce is we can reduce, rather than 0 plus k pi, we could then just write that as k pi. And there is a good solution for A. Okay, let's jump in and let's tackle B then. Now, I'm just going to sneak in my solution to B down here just so we can kind of see it a little clearer. Okay, the first question I always ask myself, do those B's repeat at regular intervals? The answer is no. These two B's are really close together, and then it takes me a lot longer to get to the next B, and then a shorter distance. All of those B's are not equidistant apart. So my answer to the question was no. That means I need two statements. So maybe I start off with rising to a value of B, or to a value of -1/2. So I'm going to pick a point anywhere on my graph where I'm rising, and maybe what I'm going to do is I'm going to highlight this B. I know that I'm rising at that, and that angle measurement would be -π/6. I know that I'm going to be rising to be any full rotation of my sine curve, and my full rotation of my sine curve is 2 pi, so therefore I need to add on my 2k pi. Okay, now I need to address the falling to B. Well, again, it doesn't matter which B, but maybe I select this falling to B. That is going to be a π/6 past pi. So that point is going to be a 7 π/6. And then I know that I'm going to be falling to B any full rotation in either direction, so I can add on my 2k pi. Okay, let's fit in one more together for this one, and we'll see if we match up in the end. So what I would like everyone to do is now go ahead and write a C on your picture wherever you see a value of -1/2. Sorry, -1. So we have a value of C and a value of C. What I want you to do now is pause the video and try to write your general statements for that value. Okay, we're back. So These would have been the two possible statements that I would have expected to see. Again, there's infinitely many, but I would have expected to see one of these two. So maybe we looked at and we chose this C value. So we said theta equals. We asked ourselves, do those C's repeat at regular intervals? And our answer should have been yes. Now, you don't see any more C's on that graph, but you do know that if you were to extend your sine curve back, you would have another C back here. So since they occur at regular intervals, then we only need one statement. And so maybe we chose that boxed in C, our negative pi by 2 value, and then we said how far apart does it take to repeat those? Every full rotation, so 2k pi. I could have expected a lot of people to have given me this statement instead. That instead they focused in on the circled C and said that at 3 pi by 2, I know I have a value of negative 1, and then I add on my full rotation in either direction. So that should hopefully give us a little more confirmation as to how we go through and generate general statements. Okay, finish off D for question 2, and then if you take a look at page 2 of that handout, that's going to be your practice for today. Can you work your way through and create general statements for your curves? Okay, I'm hoping that this video made sense, that we are able to kind of inch our way forward into general statements, and that no one got distracted by the crying baby in the background during the first 5 minutes. Okay, good luck with your practice today, guys.